And welcome back. And it's Corbett 5 a day higher plus, and it's for the 18th of January. Let's start with today's questions. All right, so what do we have here? So rearrange y plus 3 equals to make y the subject. So in other words, I need to do some rearranging, so I end up with y equals something. So the first thing that seems obvious to me is let's expand the brackets. So that gives me y plus 3 equals xy plus 2x. Now, because I want it y equals, I'm going to move everything with a y to the left and everything without a y to the right. So that's going to give me y minus xy is equal to 2x minus 3. Then I'm going to factorise the y out, and you'll see why I do that in a second. So that's going to give me y1 minus, sorry, it's not 1 minus y, y1 minus x is equal to 2x minus 3. And then divide by the 1 minus x, which is for the y on its own, and that gives me 2x minus 3 divided by 1 minus x. And that's the first question done. Next question. It looks like we've got a vector coming up, doesn't it? So write down a vector that is perpendicular to AB and twice to the length. Okay, first step's relatively straightforward. So if something's perpendicular, so whereas this goes across by 2 and up by 4, a perpendicular vector will do the opposite of that, as in it will do it the other way around. So therefore a perpendicular vector would be something such as 4 minus 2. And again, if we draw it on here, it's slightly easy to see. So if I draw a vector on the grid that's going across 4 and down 2, well, across 4 and down 2, obviously I'm going to have to go slightly off grid, but you can see that is pretty much perpendicular. That does indeed work. Okay, and the second part wants me to do twice the length. So twice the length is going to be 8 minus 4. Now in an exam, make sure you're highlighting what answer you're presenting. In this case, it's the one at the bottom, just so they can see which one your final answer is. Next question. Okay, so we have a Venn diagram with a lot of probabilities in, and it says work out the probability of not being in A and keyword, because it's intersection, so both must be true, and not being in D. Okay, so because I can do and, I can start crossing things out. So therefore I don't want that one because that is in A. So basically I don't want anything that's in A, and I don't want anything that's in D, and it must be both not in A and not in D, so therefore it's going to be 0.13. But I'm starting to wonder whether there's something clever going on here. So if I get my calculator out quickly, and what I'm going to do, let me delete these so you can read them again. I'm going to add these values up. So if I add these values up, I've got 0.88. So in other words, I also have 0.12 here, which means it's 0.13 plus 0.12, which equals 0.25. That's a nasty little question there, but very well presented. Well done. Next question. It says factorize this. Now, because it's a factorized question, I'm going to do the factorizing technique, and I'll do it properly. I would say the guessing method will work, and I would argue that the 14 is probably going to be 7 and 2, and you could probably have a good guess. But let's do the slightly longer method anyway. So I've got 14 times minus 10, which is minus 140, and then I need a combination of those two things that gives me 31. Well, 140 is going to be, we'll start with the obvious one, so it's 70 times 2, it's nowhere near. It is also 35 times minus 4, because half of 70 and then double the 2 gives me 35, which means I can write this as, now although you're used to doing it without the y is basically just add it on like you would the x. So I'm going to write this as 14x squared plus 35xy minus 4xy minus 10y squared. And then I'm going to factorize this bit here, which is going to give me, I'll take out a 7x, and that's going to give me 2x plus 5y. And then I'm going to factorize out a 2y on this side, and that's going to leave behind 2x minus, well, minus 10 divided by minus 2 is plus 5, and there's a y left over. Now, quick check, these two things must be the same, and they are, so it's great. So that means my final answer is going to be 7x minus 2y multiplied by 2x plus 5y. In short, the y, which I think most of you might have thought, what do I do with that? Actually, you can just treat it like you would the x, and you've just got two variables floating around. Good question. Final question today. After a reduction of 3% in the original price, a motorbike is sold for 700. So in other words, I've got a multiplier of 0.97 and 700 being my selling price. Both of these, oh, great. This is why you read the whole question before you carry on, isn't it? Both of these values are correct to one sig fig. All right, so the 3%, well, the sig fig above is 4% and the sig fig below is 2%, which means it's between 3.5% and 2.5%. Now, if I want the maximum possible original price, I need to have discounted the most, which means I add the most back when I undiscount it. So therefore I'm going to use 3.5%. And 3.5% is going to give you a multiplier of 0.965. Yeah, that's right. So I quickly think that one through. It's a good question. And then equally 700, I want the maximum price it could be, which gives me the maximum price when I take off the discount that's happened. So to one sig fig, the sig fig above is 800, which gives you 750. Now, this is an interesting one because pounds and pence are technically discrete. So really, I should actually not have 750. I should have the number that's the smallest number below, which is £749.99p. I wonder whether the mark scheme would have allowed both, because pounds, whilst discrete, they're very, very small units. But I'm going to stick with that because I think that's technically the right way of doing it. So that's 749.99 divided by the discount factor, which is going to give me, get my calculator out, so 74999 divided by 0.965, and that's going to give me 777.19. So it's going to be the original price of 777.19. Now, again, this 749, it is correct. It is the right way of doing it. I wonder whether an exam question would make it a bit clearer or allow both, because I think you can make a good argument that 750 for the element of the rounding makes it close enough. But either way, good question. Nice sort of difficult, interesting question to end on. Definitely a bit of a debate, I would imagine, amongst some teachers, but I'm happy with the way that I've done it. And that is the 18th of Jan done. Well done if you got those right. And as ever, do like and subscribe to the channel, and I will see you for the next one. Thanks all.